to please lead us in prayer. Kurt, please. Hello, Kurt Istoke. Can you please lead us in prayer, Kurt? Can I ask then Desiree Galchano to please lead the prayer? Desiree, can you do this? Yes?
Ma'am, can you hear me po?
Kindly lead the prayer.
Uh, can you hear me po?
Yes, I can hear you clearly.
Okay. Let us all bow down our heads and feel the presence of the Lord. O God Almighty, bless thy loving children, offering to you today our works and studies. Help us, dear Lord, to be obedient to our teacher, kind to our companions, and diligent in our studies. And that will be merry for the blessings of ourselves, our school, our beloved country, the Philippines. Amen.
Okay, thank you very much, Des. So good morning once again. Okay, to check your attendance manually, I have to check your attendance manually. When I call your name, don't say present. Instead, you're going to share with us your favorite food. Okay, favorite food. So that would indicate that you are there in the meeting. When you say when you share with us your favorite food when your name is called. Bea, Baldo, Elian, Sebrian, Ram de la Fuente.
Ma'am, morning.
Morning. What
Okay,
is your favorite food, Ram?
my favorite food kay kuan siya dessert siya cake.
Okay, thanks, Ram. Can I have
Thank you, ma'am.
Michael, Delphine?
Morning, ma'am. My favorite food is green mangoes po.
Okay, thanks, Mike. Can we have next Rafa, Delphine?
Morning, ma'am. My favorite food is scrambled eggs po.
Okay, thanks, Rafa. Can we have, okay, Kurt Istoki, you just have to chat in the chat box. Can we have Nicole Fabre?
Mom, my favorite food is pork sisig.
Okay, thanks, Nicole. Can we have next Desiree Golchano?
Favorite food po is pasta.
Okay, thanks, Desiree. Can we have Jerry Ter Gondaya? Can we move on to Elaine Hojas? How about Kent Horlador? Let's have Asnay Lau. Asnaira? About Max Legaspi.
Hello, ma'am. Good morning. Egg, ma'am.
Okay, thanks, Max. Can we have next Charlotte Lumopog for a while? Sorry for that. Can we have now Charlotte? Can we have next Ashley Malazarte? Ashley is
Good
here.
morning. My favorite food is tofu po.
Okay, thanks, Ashley. Next, Mohammed Manire. I think he's not in the meeting. Can we have Kylie Nemaria?
My favorite food, ma'am. Anything spicy.
Okay, thanks, Kylie. Can we have Isabella Oculares? Okay, Isabella is not here. Can we have Heinz Opesio? Are you here, Heinz? Not around also. Can we have Tiffany Pagara? Hi, Tiffany. How about Harley Palmes?
Ma'am, regarding Harry Palmer's mom, naka-request daw siya pero wala pa siya na-accept.
Okay, I'll check. But I have accepted yesterday. I'll try. I'll check the request. Okay, how about Simon Pimentel?
Good morning, ma'am. My favorite food is chicken adobo.
Okay, thanks, Simon. Can we have next Claire Pumikpik? Claire? How about Eliseo Kilab?
Good morning, ma'am. My favorite food is homba.
Okay, thanks, Eliseo. Next, can we have Clyde Santiago? Can we have Sharifson Sarapudin? Okay, kindly I placed the link already in the chat box for, can you please share it to anyone who has not been accepted yet in the teams, because I was not able to check, and the last time I checked, the request was yesterday afternoon at 4:30. Can we have now Ray Soria, Jasmine Soria?
Yes, good morning, ma'am. My favorite food is crabs.
Okay, thanks, Jasmine. Can we have next Candy Tandoy? Can we have Fritz Tatad?
Good morning, ma'am. Favorite food mo, may mango float.
Okay, thanks, Fritz. How about
Excuse me po,
Keina
ma'am.
Karel Billones?
Present, ma'am.
This is Candy.
Yes, ma'am. Good morning,
Oh,
ma'am.
you have to share what's your favorite food, Candy.
My favorite food po, ma'am, is chicken.
Okay, thanks, Candy. Can we have now Keina Billones?
Yes, ma'am. Good morning po. What was the question, ma'am? I'm sorry.
You share what is your favorite food.
Oh, my favorite food, ma'am, is pesto pasta po.
Okay, thanks. Did I miss someone? Not called?
Good morning, ma'am.
Yes.
I was called already, ma'am, but I was just able to join the meeting now.
Uh, may I know your name? May I know who is speaking?
Asnaira, Asnaira po.
Asnaira Lau. Okay, sige. Can you please share what's your favorite food, Asnaira?
My favorite food po is it's a Maranao dish. It's called pindialo. It's a
Okay,
chicken.
sige. Yes, yes, I know that. Because we have a colleague who is Maranao also. Sige. Okay, thank you very much for sharing. So I hope you are in learning a place which is conducive to learning, no? So because that is very important. Anyway, we'll just have it for at most 1 hour and 15 minutes. So can I have some reaction there, some thumbs up if you are ready for the discussion for today? Okay, thank you very much. Thank you very much for your reactions. Okay, so I guess you are ready for today's discussion. This is very important because you will need an understanding of this discussion, or the lesson, in order for you to answer short quiz 2, which will be given on Friday. Okay, so let's start with our discussion for today. So we're going to discuss now just a continuation of what we had last meeting. So we'll just do it slowly. Anyway, we are still on track for the schedules. Again, good morning. So let's make this day productive. So let's try to do something productive as well. So For today, as I have said, we're going to discuss a continuation still on sets because we have not done the discussion on sets yet. So please join classpoint.app again. This is okay, this is to motivate you, of course, the very purpose of that. So in order to have additional points for your short quiz too, you need to have you need to participate in today's question and answer portion through classpoint.app. Our code for today is 59920. 59920. We have already 9 participants in the app. Okay, we're waiting for some more because you're supposed to be 17 in the meeting. Okay, 14. Thank you very much for participating. Waiting for some more. If ever you really cannot join because of your internet connectivity issue, you just can have your answer submitted before, of course, the correct answer is given in the MS Teams chat. Okay, so for the first question, I'm going to ask you this question. Just share a bit of your what was easier today than yesterday. So although we are still we it's still 9:16 in the morning, I know you already found something easier today than yesterday. Just one word so that it will be highlighted in the screen. Did you find the question difficult to answer? More difficult than the question about our lesson? I hope not. I hope you can recognize something that is better or easier today than yesterday. Let us just try to count the blessing that we receive each day, and that would give us more energy to move forward and look forward to what will be better tomorrow than the other day, right? So I hope that will inspire us to move forward and be excited for another day to come. Okay, 11 answers are in. I hope the others would also answer. We are already 19 in the app. Okay, thank you very much. Okay, smoother. And then waking up early is easier today. I'm glad that you found it easier today. Answering, doing assignments, very good. Being happy, improving. Sleep is improving, and then writing paragraphs. Okay, waking up early. So I'm glad that you found it easier today. So there will still be easy things to happen tomorrow, and we look forward to that thing. So thank you so much for responding and for participating. So for today, these are the steps that we are going to learn for today. We're going to review the three methods to represent sets. Actually, we have not dealt yet with the third method to represent set. Next one is we are going to determine the cardinality of a set or the set's cardinal number. Thirdly, we will recognize and apply equivalent sets, equal sets, subsets, and proper subsets. I know these things ring a bell to you, but we're just going to refresh, okay? So I hope you won't get bored as we go along. So we have determined the number of subsets and proper subsets of a given set, and we are done for the day. Okay, so let's have a quick review to refresh you what we have discussed last meeting in case you have not gone through your notes yet before coming to class. So we discussed or we describe what a set is. So to refresh you, we define a set as a well-defined collection of distinct objects. So uh, the adjectives well-defined is very important, and also the distinct objects. That's why it tells us that you're going to write the elements of a set uh, distinctly. Then we classified sets as either finite or infinite. So it's important that you know how to identify a finite set from an infinite set, because later on we are going to talk about something that is exclusive for finite set only. That's why you need to understand. When you say finite set, when you count the elements of a finite set, you will come to an end. There's an ending, right? So while in infinite set, there is no ending in the counting. You continue counting and there's no end. That's the very, I think, that's the easiest thing to remember about finite and infinite set. And also, we have discussed about the common number sets, right? So I'm now making a diagram to make it easier to remember. So for example, we have the largest set so far that we have discussed, but you know there is still a bigger set than this set here. So that's why it is placed on top. We have the set of real numbers denoted. Okay, we use the symbol to make it shorter. We use the symbol letter R, the capital letter R, to indicate the set of real numbers. So all of this that are under that box for real numbers are all real numbers. So just to be very particular, because each of these set has their specific characteristic, we classify real numbers as, or we categorize into two groups. We have rational numbers where we use the symbol letter Q, and the set of irrational numbers denoted by I. So when we say rational numbers, these are the numbers that can be expressed as a ratio of two integers. To distinguish it further from the set of irrational numbers, when the decimal approximation of a rational number is a terminating, meaning to say it will stop. The rest of the digits will then be zeros, then it's a rational number. Or it could be a repeating decimal. Repeating, for example, we have 1/3. If you get the decimal equivalent of 1/3, it's 0.3333. The digit 3 will repeat. Therefore, those repeating decimal representation corresponds to a rational number. While when we talk about irrational numbers, these are the numbers which cannot be expressed as a ratio. Some examples are square root of 2. You will know that square root of 2 is an irrational number because its decimal equivalent does not terminate. It's non-terminating and non-repeating. You won't see a group of digit or a digit being repeated in its decimal value. Those are irrational numbers. So square root of 2, square root of 3, and then pi, some of those. And then they're multiples. So we have also, okay, when we talk about rational numbers, to make it easier to identify, this could be the set of integers and the set of fractions. So we say fractions, these are the rational numbers whose denominator is not 1. While when we say integers, these are the rational numbers whose denominator is equal to 1. Right? So for example, 100 can be expressed as 100 over 1. Its denominator is 1, so it's an integer. While a fraction, so we say 1 over 10. Okay, so these are fractions. All of them are rational numbers. And then further, the set of integers is can be categorized into these groups. We have the set of positive integers, which we also have called as the set of natural numbers. These are the numbers 1, 2, 3, 4, and so on. And then we have the zero and we have the negative integers. If these three will be put together, that they constitute the set of integers, which we symbolize using the letter Z. Okay, so if we also put together 0 and the set of natural numbers, we have the set of whole numbers denoted by W. So these are the numbers that we dealt with. And I am emphasizing this because we will be using them later on, especially their symbols. Right? So I hope we're good with that. You can still remember that. Okay, recall also the notations for element and not an element of. Okay, so element meaning it is a member of the set. So we say 2 is an element of the set N. What is this set N? The set of natural numbers. 0 is an element of the set W because W is the set of whole numbers and 0 is a whole number. But we say that 2 is not an element of the set of irrational numbers because it is rational. And we say also that 1/2 is not an element of n because it is not a natural number. Okay, are we good? So I hope so. So if you recall also, I mentioned about the three methods for representing sets. We had the first one is the statement form or the descriptive method. The second one is the roster method. So in the descriptive method, we merely describe what what are the characteristics of the objects that will belong to the set. So just in sentence form. While in roster method, from its name roster, you need to list the elements really one by one of the set, enclosing them in braces and then separating them by commas. While in set builder notation, the very purpose of this notation especially is for naming infinite sets. Okay, and we're going to discuss how are we going to denote or how are we going to represent a set using the set builder notation. So you have to take note that you should know how to transform one form to another. Last meeting we had discussed how to write a set represented using descriptive method to roster and then from roster to descriptive method. So you will see later on the need. Why do we need to transform one form to another? This morning, we're going to have the third method of representing sets. We have the set builder notation. So the set builder notation, so you just have to build the set. It's actually more like it's a combination of the statement form and the roster form. Why would I say a combination? Because in the roster form, we use braces, right, to indicate the set. But we are not enumerating it. We are describing. Okay, we are describing the elements that should be contained in the set. So for example, we read this as the set of all elements X such that X is an element of N and X is greater than 7. We enclose the set in braces, but what we enclose in braces are not the elements, but the description of the elements. The reason why I recall the common number sets with their symbols is that we will be using them here when we describe the elements of the set. So by the way, sometimes the bar there is written also as double dot. That is a colon. It will still be because these are the commonly used symbols. The set of all elements X such that, that is still read as such that X is an element of N. This is also a possible notation so that you won't get confused when you encounter one like this in some other books or some other worksheets that you will find in the internet. Okay, so this is the set builder notation. It is especially useful when describing infinite sets, just like this set here. So although we can describe, we can note or represent infinite sets using the roster method using the three dots, this would be better. Okay, because it's compact. Okay, and this is the usual notation we use in our in mathematics, in pure mathematics. As I have said, it's important that you know how to transform one representation to another representation, as you can see later on. So that if we're going to write, for example, this set in roster form, we would write it as, okay, so we have, you identify or you list the numbers which are natural numbers because it's described that it should be natural. And then it should be greater than 7. So if it's greater than 7, recall what are the natural numbers greater than 7. Okay, so greater than 7 natural numbers, we start with 8, right? 8, 9, 10. And we know that this is an infinite set. So when you indicate or represent a set, infinite set in roster method, we just make use of these three dots so that it tells the reader that it continues in that pattern. Right? So I hope it's clear. The the set builder notation. So here are the symbols just to refresh you again on the symbols that we use. For real numbers, we use R. For rational numbers, we use Q. For irrational numbers, we use I. Integers, Z. And then, okay, we can indicate the set of negative integers as Z superscript minus, Z minus for the set of negative integers. And the set of positive integers can be indicated as Z plus, which also are the natural numbers where we denote using N. And of course, if we put if we put together zero and the positive integers or the natural numbers, that gives you the set of whole numbers W. I hope it's clear now what are the elements of those set because you will be needing them in our succeeding discussion. Okay, let's try to use now the set builder notation to write the set of integers less than negative 3. Okay, so to write it in set builder notation, we do have an open bracket. Okay, open bracket there. I'll make it better. An open bracket. Okay, then you just have to use any letter in the English alphabet. So shall we say I'm going to use Y because I don't want to use my X. So the set of all Y such that Y is an element of. What is the number set that is being mentioned in the description? It's the set of integers. What was the symbol for integers as we recall? It's Z. So Y is an element of Z. It's not only an integer, but it should be less than negative 3. So there are two characteristics that we have to point out. And Y should be less than. What's the symbol for less than? Like that. Less than negative 3. And this is the set builder notation for that particular set given in statement form. Okay, so are we good with that? So I hope so. Or you can make use of X, ha? That depends upon you. What letter are you going to use? As long as it is not the same as our common number sets notation. Next is the empty set. I know you know what the empty set is, right? So I think this is one of the sets that you will never forget in your lifetime. So you see empty from its name, it's the set that has no elements. No elements. So it is called the null set or the void set. And take note of our notation. When you see this, it's easy to remember because it's just a zero and then a slash, no? No element at all, or these two braces with nothing in it to indicate the empty set. Now it's your turn to answer two questions. Please get ready with your class point that up. I'm going to ask you to answer these two questions. Shall we start? First, we have This question, I sorry, yes, that one. It's just a simple true or false. The set of negative natural numbers is an empty set. By the way, I'm going to stop the close the submission when the time strikes 1 and 30. Because this is just a true or false question, and then I think it's answerable for 1 minute, but we'll extend it for 30 seconds. So please answer now. I think the question is quite easy, right?
Ma'am, you're
Excuse me
not
po,
audible
ma'am.
po.
Nakamute ka po.
Okay, thank you, thank you. These are okay, the set of natural numbers. Okay, I have shown you already, no? The answer is true. Why is it true? Because the natural numbers contains one, 2, 3, 4, and so on. Do you see any negative natural numbers there? Nothing. Therefore, it is an empty set. Clear? Okay, so for those who answered false, it's okay. You still get half of a point. I have another question, so get ready. This is good for, I think, 30 seconds only. Time pa, dili pa. Sorry. Next pa di ay. Sorry. I'll discuss one more concept. The cardinality of a set. I think you have an idea what it means by cardinality. When you say cardinality, this is a characteristic exclusive to finite set. That's why I pointed out earlier that we need to identify really a finite set from an infinite set because there is a characteristic that is exclusive only for finite set. And that characteristic is the cardinality. So when we talk about cardinality, it is exclusively for finite set. We don't talk about cardinality of an infinite set. So this is the number of distinct elements. Very easy. Number of distinct. Take note of this. This is very important. Distinct elements in the set. It's because why I highlighted that? It's because sometimes you might be pranked. Some of the elements in the set are written repeatedly. However, when we say cardinality, it should be just the number of distinct elements in the set. Or the other term would be cardinal number of the set. And the notations are either this, n of A, just to make you remember quickly, n is number of elements of the set A, or this absolute value sign. Do not confuse yourself with the absolute value sign. It's not the same as absolute value sign because what you see inside is a capital letter. So when we have the absolute value sign and then a capital letter inside, it means cardinality of a set or number of distinct elements in the set. For example, this is what I told you earlier. You need to remember that it should be the number of distinct elements because in here, zeros are written 3 times. We just have to count one of them. Okay, so 1, and then we have 4 is written twice, it should also be counted as 1. And then 9 is written twice, so it should be counted as 1 as well. Making the cardinality of the set D n of D as equal to 3 because there are only 3 distinct elements. Okay, it's your turn next to answer. Please answer this question. What is the cardinality of the empty set? Okay, turn in your responses because it's just good for, we have 15 seconds left. Okay, very good. 16 gave letter A as the answer, and that is the correct answer. So, why 0? Because we know that the empty set has no element, no? Diba? There is no element, or the empty set has no element. Therefore, its cardinality is equal to 0. Congrats to the 16 who got it right. Okay, so next, we have this question again. It's good for 1 minute anyway. So which of the following statements is true? You may answer more than one because there are actually two correct answers here. Please click on the two correct answers. Okay, three answers are in. Four now. Five, six, seven. Okay, time is up. Thank you very much for participating. The correct answer here is A and B. Okay, congrats to those who answered A and B. Which of the following is true man, right? The question is true. The cardinality of set C is 5 because we have 5 distinct elements here. 1, 2, 3, 4, 5. The cardinality of the set D here, it has one element and that is 0. So it's 1. This is correct. This is correct. Cardinality of E, since E is the empty set, we have answered it previously, is 0. So this one is false. Okay, so anyway, just go on participating. You still earn one half of a point. So let's have the next concept. Easy. This is easy because this is discussed even in kindergarten. Yes, they have been introduced with this. If you have brothers or sisters, if you can remember your kindergarten lesson, that's how many years ago. So what do we mean when we say equal sets? Take note of the notation. It's just the symbol for equality, right? So equal. We say that two sets are equal if, this is the requirement, they have exactly the same elements, although not in the same order. So for example, the set A contains 5705 and the set B contains 057. They are equal sets because they have exactly the same elements 0, 5, and 7. That's the concept of equal sets. And then we have equivalent sets. You might be asking, are they not the same? No, in mathematics, it's not. Equivalent sets are denoted by this notation, the tilde there. We say A is equivalent to B if and only if they have the same number. That's just the requirement. The requirement is simpler. Same number of elements. In contrast to equal where they have exactly the same elements. This one only number. So are you convinced with this that equal sets are equivalent sets? All equal sets are equivalent sets. So when we say equal sets, they have exactly the same elements. when we say equivalent sets, they have the same number of elements. So if they have exactly the same elements, they have the same number of elements also. Therefore, all equal sets are equivalent sets. What's the converse of this statement? The converse of this statement would be all equivalent sets are equal sets. Or are equivalent sets equal sets? Okay, no. It's false. That's the converse. That is what we meant by this. However, the converse of this statement is false because clearly, if we have two equivalent sets like this one here, they are not equal sets. This one is a counter example. Okay, so suppose set A contains how many? 6 elements here. And we have set B here. Okay, the requirement for equivalent is we should know how many elements are in each set. Can we tell if we are, what type of representation of this? Is set B given? Set B is given in set builder notation. And when it is in set builder notation, you cannot directly tell the cardinality or the number of distinct elements the set has. What are you going to do? We are going to represent it in another form. This is the thing that I pointed out earlier, that there is a need in some cases to transform one representation to another. So we would have to enumerate the elements of this set. You are going to have the elements which are natural numbers. And in this range, 1 is less than x and less than 8. So what must be these natural numbers between 1 and 8? These are 2, 3, natural numbers. 4, less than 8. 5, 6, and 7. As you can see, A and B are not equal sets, but they have the same number of elements, and that is 6. Therefore, A is just equivalent to B, but not equal. Okay, I have 2 questions that you are going to answer next, so get ready. The next question will be, which of the following sets are equal? Okay, you are going to answer. There's only one answer for that. So you are given 30 seconds to answer and you have 15 seconds left. So turn in as fast as you can. Okay, so your internet connection might be slower and that would affect how fast the answer will be turned in. You may just chat your answer in the box as before I would reveal the correct answer. So those who have not submitted, please chat your answers because that will still be noted. Okay, thank you very much. So the correct answer here is, tada, it's letter C. It's letter C. The sets in letter C are the ones which are equal. It may not be that obvious. Okay, so it's not ano naman, it's not fair just to give the set the same way, right? So this will really force you to transform one representation to another. When we talk about equivalent and equal sets, we really need to have the set written in roster form, right? So you need to transform one form to another. The set of first 5 natural numbers are 1, 2, 3, 4, 5. They are equal sets. If you look at these two here, it's not that easy to tell if they are equal or not unless, okay, this is a roster method already. We have to have it in roster method. So you have x is an element of w means whole numbers less than or equal to 5. What are the whole numbers less than or equal to 5? These are 0, 1, 2, 3, 4, less than or equal to 5. So it must include 5. It's there. While, so clearly they are not equal. How about the elements of this set? These 3 dots here would mean that it continues on that pattern, meaning to say it would include 35, 40, 45, 60, 65, 70, 75, 80. And how about this set here? This indicates the elements of this set are natural numbers less than 17. What are the natural numbers less than 17? 1, 2, 3, and so on. The last entry would be 16. So you will see now how important it is to transform one form of representation to another. I hope you have realized it now. I have another question for you to answer. So get ready because it's still for 30 seconds only. Okay, the question is which of the following sets are equivalent? There are more than one correct answer. So please try to check all answers. Okay, thank you. Why is the okay? Ah, there's no letter D ha. There's no letter D. Who answered D, Ben? Nag-click lang siguro dire-diretso. The correct answer here are actually all those choices are correct. These are equivalent set. As you can see, they have 6 elements, both of them. That's the reason why I earlier mentioned the elements of the set to give you an idea if you are really paying attention. This one, if you count the number of elements, including 35, 40, the one that I mentioned earlier, and this one also has 16 elements. These are equivalent. And of course, earlier, we identify these as equal sets, right? And we know that equal sets are equivalent sets. So all of them are true. So congrats to those who responded, except for the one who answered letter D. I'll try to see who is that. Okay, so we're almost there. This one. I want you to answer this. Okay, stop sako ha. Stop sako. I'm going to go back. The next question will be paunahan. Whoever got it right, I will be giving a 50 peso load later. First one nga correct. Pero if you get it right, although you're not the first one, you will still get 1 point, additional points. Okay? So, ang first one lang nga correct will receive an extra reward. And 50 peso load. That's why if you will be the first one to answer, you will give me the your number later on where I'm going to give the load. Okay, this is just a game, not related to our lesson. Just to let you breathe in for a while. This is a maze. So you're going to trace where you're going to pass through the maze, getting inside in this part and take your exit here. Okay, this is drawing. You are going to draw it in your gadget. So if you're using a laptop, use your mouse. If your gadget is touch screen, okay, you just have to use your the stuff that will make you touch the screen of your gadget. That's a maze. That's just for a game, no? To for you to take a break for a while. Yes, there's one entry already. I'm excited. Who is that first entry there? But I will not reveal yet the answers because the others might have an idea on how you're going to get through the maze. Just keep trying. If you were trapped already when you go through the maze, just do it again. It will allow you to do it again as long as the time is not over yet. Yes, I will load GoStar 50 if you are if your telecom is Globe. Okay, so you have your answers. I think many of you got it right, but let's see who submitted first and got the answer right. So we have here, I think this is the first one, the first answer. And the first answer goes to, tama ba? I'll just have to review first, ha? Because I'm not so sure how to determine who submitted it first. Pero so far, this one is the first one for that is submitted by Ram. So later on, Ram, please PM me the number where I'm going to give the load, and you tell me the telco that you are that is being used so that I would know. Yes, sana all daw Ram. Ram might be very quick in answering. Pero those who got this pattern right, you still get the what plus the additional point, the additional 1 point. Okay, congrats, Ram. We'll have na the last one. Last one na niya. We're almost done. So we have here subset and proper subset. So from the prefix sub, we know how what we associate with the word sub, right? It's part of, right? So it's under. So it's under. We have sub. So when you say subset, denoted by this notation, take note. We have that letter C and a bar down here. Okay, this is true if and only if every element of the set A, the one in the left, is an element of the set B. That's why it's not that easy, especially if the sets have many elements. You really have to check one by one. If all the elements in the set in the left here are all found as elements in the set B, only the elements of A. So, for example, we have here the set containing 2, 4, 6, 8, 10 is a subset of the set containing negative 1, 0, 2, 4, 6, 8, 10 because all its elements here are found here, same color. It's a subset. But we know that this set is not a subset of that, right? So it's not a subset because this one, if we're going to make it inverse. So we have here, this set is not a subset. Take note of the notation for not a subset. It's just the notation for subset, and then we just put a slash there. Because there are elements here that are not found there. Tong the other way around lang, which is the one which is true. So the reason why this set is not a subset because negative 1 is an element of, shall we call this as our set B and this as our set A. There is an element negative 1, at least one requirement lang if you can show that. Negative 1 is an element of B and negative 1 is not an element of A. That's the reason why B is not a subset of the set A. I hope it's clear. So take note of that and remember that so that you won't be studying so hard for the short quiz. And we have these special subset relationships. I think you're familiar with this. Uh, any set is a subset of itself. So any set A is a subset of itself. That's true. It's easy to prove or to justify. It's because all the elements of A are in A. So A is a subset of any of itself. While this one, the empty set is a subset of any set. Why? The empty set is not a subset of any set. This is not as easy as understanding or comprehending this statement here. Why? Because we would have, how will we justify that the empty set is not an empty, is a subset of any set when in fact, dapat all elements of the empty set is contained in the set A. But how come? There, the empty set has no element at all. The process of proving this is using the proof by contradiction. The proof by contradiction is done using, you are going to make the negation of this, make the negation of this statement, and then, so negation of that is making the relationship not anymore. Suppose that the empty set, that is your supposition, suppose or your assumption. Suppose that the empty set is not a subset of set A. Okay. So in logic, if you remember your logic in Gen Math, okay, so please don't deny. I know that you have logic in Gen Math. The problem now is that if you can remember or not. In logic, a statement in logic is just either true or false. Nothing in between, right? So if the statement is true, then it is not false. If it is not true, then it should be false. Okay. So what are we going to have? We assume the negation of the statement and we hope to see a contradiction so that we'll prove that this is false and this one is true. Siya, it's easy to understand. It doesn't need to be to have very good logic. So we'll prove that this supposition is false. Why? It will lead to a contradiction. It's very short. Suppose the empty set is not a subset of a set A. So we will check what makes it not a subset of the set A. There exists. There exists. I'll just use this symbol. I do not worry. We will not prove this in your exam. There exists an X. So element. There exists an element of the empty set such that, diba? Dapat kung this relationship is true, X is an element of the empty set and X is not an element, right? That is the implication of not a subset. This empty set has an element which is not in A. But take note of this. Look at this one here. Is this correct? Is this correct? This is not correct because we said that the empty set has no element at all. Why would we say that there is an element? This is also already what we call as the contradiction. And since our assumption leads to a contradiction, this one is false and we have proven this as true. Right? Amazing, right? Logic is actually uh, very interesting. That's why later on, if you are taking if you are taking business management, I know a lot of students pursuing law because logic is very important when you take up law. So enough for that. So we have the notation for not a subset. Don't worry if you cannot prove it that way. We will go back to that when we come to logic in module 3. Balikan nato. So we have that notation as not a subset. And we say that the set of whole numbers is not a subset of the set of natural numbers. Why? What are the numbers belonging to the set W? We have 0, 1, 2, 3, and so on. While N, so these are the elements 0, 1, 2, 3, dot, dot, dot. That's for W. While for N, these are 1, 2, 3, and so on, right? So what makes it not a subset? Because W has 0. 0 is an element of W and 0 is not an element of N. That's the reason why it's not a subset. Okay, good. We'll proceed. We're almost done. Just be patient for ano, more some little minutes na lang. Set A is proper. Okay, we have another concept. Uh, a while ago we defined subset. This time we'll have proper subset. What we meant when we have A being a proper subset of B, take note of the notation here. There's no more bar down here. That's the difference in the notation. Earlier, we have subset as A is a subset of B. But when we have proper, this is already gone. Why? Why would we erase that? Because A is a proper subset of B. Tells us that every element of a set A is an set B is an element of a set B, meaning to say it should be a subset first. But there is additional condition. They are not equal sets. Because if you have a subset, they can be equal sets, di ba? We can have A as containing 0, 1, 2. It's a subset of a set containing 0, 1, 2 because the requirement there is that all elements of A should be present in B. However, we see proper subset, but in this case, they are also equal, right? So, but it is true, proper a subset. But if we have A there as 0, 1, 2, we would say that 0 is not a proper subset of B. It's because they are equal. The requirement for proper subset should be not equal. So how would we make A para it will become a subset? Suppose we will have A as containing 0, 1, 2. To make it a proper subset of B, we have to make B to have one more elements more than A. Kasi at least one. In this case, A is a proper subset of B. They cannot be equal. That's the difference. Okay, so if we have subset, they can be equal sets. If proper subsets, they cannot be equal sets. That's the difference now. So we have here an example. Let me erase this. We have A and B. A contains 1, 2, 3, 4. B contains 1, 2, 3, 4, 5. A is a subset of B, but A is a proper subset of B because they are not equal. B has more elements than A. Okay, I hope claro si proper subset. Next is on counting how many subsets and how many proper subsets does a set has. Okay, let's see. Let's do it one by one to make it better understood. So how many subsets does an empty set have? Remember the subset relationship? The empty set has a subset which is the set itself. That is its subset. How many subsets does a set with one element? Shall we say the element is 1? How many subsets does this set has? Uh, the empty set is a subset always of any set, right? So it is a trivial subset. And then the other subset would be the set itself. It's a subset, right? So a set with one element has two subsets. How about a set with two elements? Shall we say the set contains 1 and 2? What are its subsets? Its subsets are the empty set, the set containing 1, di ba? This is a subset because it has its elements in the other set. The set containing 2 also. And then of course the set itself, di ba? We have that said earlier, a set is always a subset of itself. They have 4. So the number of elements here is 2. The number of subsets is 4. The number of elements here is 1. The number of subsets is 2. 0 element, it has 1 subset. If we're going to have a set with n elements, how many subsets would there be? It's here. It has 2 to the n subsets. That's why if it's an empty set, its subset is 2 to the 0. It has 1 subset. If it has 1 element, it has 2 subsets. If it has 2 elements, it has 4 subsets. How about a set with 7 elements? How many subsets would it have? It's 2 to the 7 and it's 128. Please remember this formula. And then for the next one here, how about the number of proper subsets? Proper subsets ta. When you see proper subsets, we exclude the set itself, right? If it has 2 to the n subsets, we exclude the set itself. The number of proper subsets would be, any guess? 2 to the n minus 1. Why do we have this minus 1? Because we have to exclude the set itself because we are talking about proper subsets. Okay, that ends our discussion for today. And congratulations for completing this module. Ay, napay example. How are you going to list subsets of the set H ni siya ha? I don't know why it became Y. How will you, although you will not be asked of this in the exam, but you might be asked which of the following are subsets of the given set. So how are you going to list the subsets of a set? So this is a four-element set. It has four elements. The elements are soft drinks or sodas that are sold in a school canteen. How are you going to list the elements of the set? Okay, we'll organize it so that you won't miss any subset. The set with zero element, it's the empty set. The set with one element, what are you going to do? You just pick each one and put them in braces. Isa-isa lang. Each one of the elements. We have four elements, so we have four subsets with one element. We'll have the subsets with two elements, pair each. Pair lang. Pair. Every pairing should be exhausted. Okay? Pair, pair, and then which one have we not paired? This one. So pair all of them by two. So that makes six subsets with two elements. How many do we have now? 1 plus 4, 5 plus 6, 11. Let's have three element subsets. The three elements, pick any three. Make sure you exhaust all three possible pairings. We have 4. So 11 plus 4, 15. Of course, with 4 elements, the set itself. That makes 16 subsets. And we can correct it with the formula, right? 2 to the fourth because it has 4 elements. The number of subsets is 16. How about the number of proper subsets? We have to exclude the set itself. So we would have 15 subsets in all. Right? Okay, so I'll have the last question. Please answer this last question to complete your additional points for today. Determine whether each statement is true or false. This is slide drawing. Write your answer on the slide. So for example, if your answer for letter A is true, write T there. If true CB, write T and so on. You should have 4 correct answers to get the full credit of 1 point. If one of your answers is wrong, you just get 0.75. If you get two wrongs there, zero point 0.5. If you get only one, your score will be 0.25. That's slide drawing. So just mark off each statement with either T or F. It's easier to write T or F, right? Than the maze that we had earlier. Okay, Ram, you just chat your answer uh, in series. Uh, in series lang in the chat box so that I can review that later on. But you have to submit your answer in the chat before I would reveal the correct answer. Okay, that's noted, Ram. Okay, sorry, time is up. Okay, the correct answer here is ay gamay nga wrong. Let's see the set containing 1, 3, and 5 is a subset of 1, 5, of 9. You will see 3 is a subset here, is an element here. It's not found here. So this is false. Okay, noted for those who chatted. The set of counting numbers is a subset of the set of natural numbers. Counting numbers, the one that we know are 1, 2, 3, 4, 5, 6, 7, 8 for the counting, no? So this is true. The empty set is a subset of any set. This is true. If we have used letter I to denote set of irrational numbers man, diba? So this should be false because these are rational numbers. So it's not a subset of that. Unless we consider as the set of integers, then it should be subset. Actually, this is siguro what she meant here. Pero since we use I for irrational numbers, this would be false. So if you answered FTTF, then you will get 1 point for this. And then if you missed one, that's a deduction of 0.25. Right? So I hope you have learned something today. These are the references. You may refer to any of those books, pero these are hard copies. I only have this. If you want, I can give you a copy, a PDF copy of this. I'll try if I can upload it in Messenger. For sure it cannot be uploaded in eLearn because eLearn accepts only up to 10 MB. That's the thing with a free Moodle. So thank you for learning with me today. I hope you have produce something for today, something better, na? So, okay, you're welcome, everyone. So, I really appreciate your attendance for today. Just a reminder, we will not meet synchronously next meeting, but you will answer short quiz 2 on Thursday. Pero take note, it's not that flexible ang time ha. As I have said, to manage your time well, uh, do it during our class time so that your work won't pile up. Pero I will be as usual as the last requirement for short quiz 1. You can answer it until Saturday midnight. Just PM me if there is really some problem. We will have the next section, next meeting, so we are not really done. We'll just do it slowly, not really fast. Anyway, we are still on track. Do you have any questions, clarifications? And may I know who came in late, who were not here when I check the attendance? May I know? I'll stop the recording, ha?